Well, we got the synthesizer built. It's taken maybe about a year to start working on it.
Yeah, it took me a year to build it.
There's a, when we're all done, you come and look in the back here, there's about 1,500,000 wires here, so. We still don't have the power supply finished for this, but we'll do that over spring break, and then they'll close it up. And I would like someone to start playing with it so we can demo it at Design Day. So we can get a group together to do it. But I wanted to show you what some of the features were in here. I've been trying to go through that and make sure everything works. It's very easy to miss a wire or a connector or something, and so remarkably, everything was wired perfectly. I shouldn't have remarkably. That was what I expected from you. Yeah. But I thought I'd go through this a little bit, and I'm going to sit down and try to manipulate this, play it through speaker, and then I have an oscilloscope here. You can kind of see the wave shape, maybe. I don't know if that'll help you at all. For me, it does. But let me start over here and kind of work my way across, explain what's here. There are 3 voltage-controlled oscillators, and they can be controlled by an external input. They can be controlled just by potentiometers that are here. You can also feed other signals back that are outputs as inputs. I'll do that in a little bit. But let me just explain or show you how this one works here. It creates 2 wave shapes, this square wave and then a triangle wave. And it creates 2 different kinds of sounds, and then that's summed over here. But let's just see how this thing works first. And I'll kind of work my way through the rest of the blocks that are there. So you can kind of hear what each one's doing and go from there. But so this is the first VCO, and there's a coarse adjustment. So you had a wide range of sound, and if you feed in a voltage, you can do exactly the same thing I'm doing with the pot. So that's one source of sound. And then on the oscilloscope here, I'm showing it's a square wave, and that square wave can have, let me do this, you can change the time that it's high and low. That's called duty cycle. Whoa! Well, what's happening there now, it's high, very short compared to its long. And then just the opposite, so you get a sound effect from that. And then there's 2 more of these oscillators, and they do exactly the same thing. So I'm going to take, well, actually one more thing here. You can have a sawtooth, that's what this thing is here. So you got a ramp that's linearly changing. So make a little different kind of sound. Okay, now I'm going to take, with a patch cord, the second oscillator's output as a sawtooth wave and feed that into the log input. So you can set a base frequency here, and then you can change that. It doesn't sound all great, but just
Turn it up a little bit.
turn it up a little bit. Let me change. And let me do a square wave. So what's happening here now, as the voltage is changing, it's changing the width of the time it's high and low. And then it's creating basically what we call harmonics, and that's what you're hearing coming out of the final stage that's out here. And this is all added together from these inputs. Let me just show you putting all the inputs together, actually. Sorry, this is not going to sound about right here. Now here's the second oscillator. So I got 2 of them going, and then here's the third one. So now I got 3 oscillators summed together at the output. So that's what's going on here. You can have another external input also summed in here. So you could be playing a keyboard or something, or a guitar, and it's going to come in with that. Or you could have these oscillators changing with those signals. There's also a white noise generator, and that's also summed in there.
Full screen saver.
Summed in there also. I won't play that right now, but it just adds noise. And you can control the volume of that. So it can give you like a fuzzy sound. I was listening to some of their videos. They were doing a flute, I think, and they're using the white noise to make it sound like you're blowing through it. Okay. So that's what's going on with this section over here. Then there's a thing, well, this all goes to a low-pass filter. And what that means is you have, you pass a signal and then you block everything above it. But that corner frequency is tunable with a DC voltage. And so you can change a pot and change the frequency that comes through. So I'll do that right now. So I'm moving that out higher so you can hear higher tones. I'll turn this a little louder here. So that's adjusting what we call the corner frequency. And then there's a voltage control amplifier, and voltage controls the volume. So as I play with that, I get louder. And I can control all of these with a pot or with a voltage. So when I'm turning up with a pot, I can do that with a ramp of voltage. Then this attack release generator is like an exponential and a decay, and it makes the thing louder and softer. So let me try that here. I'll press this button and it basically activates it. Now let's work this set. So as I'm holding it, it's getting louder and then gets softer. And you can change the rate at which that's done. So it's a lot faster. You can play with both of those, the attack and the release. So you can control that. And then up in here, there's also controls to play with the attack and release of the waveform. So you get things louder and softer. Now, how you make that into a sound effect, I'm not a musician, so but that's what it's doing. Okay, and so voltage control filter, I can move which frequencies I will let through. I can do that manually or I can do it electronically. And all of these things have outputs that can be fed as inputs. And they're logarithmic, so you get a nice change over many decades of frequency. Now there's also there's a repeat gate here also. This is just a square wave that allows you to essentially do what I was doing with a button. So electronically you can also do that too. Then there's two low frequency oscillators. And one more thing about the voltage control filter. When for those that had filtering, the Q of the filter, when it gets really high, can become an oscillator. And that's what I'm going to do here. Let me turn some of these other sounds down.
I hate when that happens. I hate when that happens when you don't want it to.
Well, this is actually intentional.
Yeah, I know.
Get another tone in there too. And now I'm just going to put the output on here. You can see a little bit of what's going on with the waveforms. It's creating a sine wave. And then with the low frequency oscillator, I can move that corner frequency around. So let me do that. Turn that guy up and turn it up here. So now I can have those tones turned on and turned. I'm moving the filter corner frequency, so I'm letting different tones come in and not come in. And then I can control the amplitude with another low frequency oscillator. And put that one. So that's getting louder and softer with this one as it's controlling it. You can kind of see that on here on the waveforms.
Yeah, it's so sweet.
You can change the rate at which that's doing that. My wife asked me to stop playing with this thing today. voltage dividers that you can play with signals coming in and step them down if they're too big. This roughly works with a plus and minus 12 volt signal. So it's kind of something out of a, maybe a tube amp or something, you could attenuate it. The sample and hold is also another signal you can send to the attack release generator, and it can be controlled by another voltage. It can be controlled by one of these things. You send a signal to there, just with the patch cords in front, play with it. So those are kind of the features that are there. But that's the basic set of modules that are here. What we need is someone to play with this and be able to make music and sounds with it that we could demo somewhere. So pretty much ready to release it for playing with, either as fun time, gadget time, or get serious about trying to do something with it. So.